From ContainerDays Hamburg, this video is proudly presented by Dax IT.
As already stated, I'm Simon. You can find me on the following socials if you want to. I'm a software engineer at Kubernetes, and at the moment I focus majorly on KCP. Who already knows what KCP is or what it does? Okay, good. No worries for the rest of the people. I have an introduction to KCP. By the end of this talk, everyone will be aware what KCP is. Today, I am joined by Lovro, who is a distributed systems engineer at Upbound. So you can already guess, Lovro is doing a bit more of the Crossplane side. I'm going to be a bit more of the KCP side, but we will work together to show you how Crossplane and KCP can work together. So with this being said, we do need to start a bit at the beginning and have a common understanding of platform engineering. I'm not going to bore you with 5 slides with 10 bullets that explain every detail. For me, 2 things are important. I think an internal developer platform needs to be automated. If not, you've just built the 10th ticketing system. And it needs to be self-service, meaning that it is demand-driven. A consumer decides when they want to consume a service, and then the automation gets triggered, not the other way around. That being said, enough theory. Let's do just a practical example. So in a company, you might have a providers team like certificates or databases, and then you have consumer teams who would like to consume the services, and then in between is this internal developer platform. And a typical flow could be team B, they decide, oh, let's see what services are available. A database is what we want. We order a database. The database team is notified, and then there is some sort of fulfillment of an order. I hope this flow kind of makes sense to everyone. It's kind of relatable. Who has something like this already in their company? Everyone, perfect. You are at the perfect talk. Everyone who has his hands down, this is the perfect talk for you. With that being said, we will only focus on a subset. Like, we only have 35 minutes. We cannot talk about everything. So we're going to talk mainly about the API layer today, which is the discovery and publishing of services, lifecycle of services or APIs. And it also is that interface where you can build things on top, like a UI, approval processes, charging, and so on. But today, we're only going to focus on this green box over here. All right. Why is Kubernetes interesting in such a case as an API layer? We all know Kubernetes for container orchestration, but it also has a rather sophisticated API. And by sophisticated, I mean APIs are grouped, meaning you can know what the author is of an API, who is the author of an API. They are versioned, meaning you can see the life cycle of an API. And then using a combination of namespaces, types, and names, you can also uniquely identify an object in the API. That's one of the parts which is very suitable for platform engineering use case. The other part is the Kubernetes API is extendable. And I think this is not surprisingly to anyone, but basically there is an API called custom resource definitions in Kubernetes that allows you to create new APIs. In this example, we're creating a shirt API, and shirts have a color and a size. Perfect. 3 minutes in. We're already done. Kubernetes is awesome. That's our talk. Thanks, guys. We're done. Not really. The big thing is these CRDs, these APIs, they're a cluster scope. So everyone shares them with everyone, and everyone can create them. And it's very easy to have collisions with them. It's very hard to control it without you writing a ton of custom policies. So then you say, OK, no problem, Simon. We are rich in our company. We just give everybody a cluster. Okay, no one is nodding, so. However, even if you had this, it would still be very time intensive. Imagine every time a new consumer or a new provider comes to your platform, it takes like 20 minutes to spin up a cluster, or on some cloud providers even longer. So you say, all right, what if we just make them lightweight? So we're just going to rip out all the things we don't need, like container scheduling, like networking, and so on. We'll just focus on the API part. So we have something like this. We have multiple control planes that are stripped of all the things we don't need, and each of them has their own data store. And I think many projects have used this approach in the past, where they've gone with separate data stores, and they just give you lightweight Kubernetes distributions. However, a big issue is it's kind of a pain to share APIs between all of them. And everyone who has built syncers, like object syncers in the past, knows with Kubernetes, this is a pain, especially if you get a large number of clusters. And then it brings us to this big question, okay, what if instead of we have 3 data stores, we have just one big data store that all of them share? And this is exactly what brings us to KCP. So KCP is a CNCF sandbox project that aims to create a horizontally scalable control plane for Kubernetes-style APIs. All clear? Woo! So this, of course, is one of these really nice one-liners that perfectly describes what it does, but it's very hard to understand. So I thought the best way to describe it was with a little example. In our example, you are the stick figure here on the left. You're a member of an application team, and then larger than yourself is KCP on the right. And the first thing to notice is KCP itself is a Kubernetes API server, meaning you can use kubectl to interact with KCP. Now we also say KCP is the control plane for Kubernetes-style APIs, so it kind of makes sense that you can actually create new API servers there, and then KCP creates it for you, and it gives you back a kubeconfig that is valid for this blue box. Similar to you, another team, Team B, they could also have their own API server that's completely separate from your Team A. And then, of course, if you use the blue kubeconfig, then you would only get what's inside the blue box. You cannot see anything in the green box because it is supposed to be isolated from each other. And we do all of this using one data store. And in the case of KCP, that is etcd. etcd is the default data store in KCP. Now, there's two things I want to point out in this slide, and they're very important. So if you look on this slide, nowhere there is a Kubernetes cluster logo. And this is very important. KCP has no dependency on Kubernetes. It's completely standalone. Yes, it feels like a Kubernetes API server, but it has no need for Kubernetes. And as such, though, it can also not schedule pods, create services, engage with nodes or anything. It's a stripped down version of it. That's the first thing. The other part that's really important for me is you might have already seen I only drew the API server logo once. The blue box doesn't have one, the green box doesn't have one. And that is because these are not API server processes. KCP is not something that spins up new instances of an API server, binary and proxies to them. But instead, it's an API server on steroids that has logical interpretations of more API servers. And in order to avoid this confusion, we don't call them API servers, but we call them workspaces in KCP. And a workspace is only around 3 megabytes in RAM. That's the impact of one of these, and it gets spin up in seconds. With this out of the way, let's peel back the layers a little bit. How does this whole thing work? It sounds a bit like magic, so let's demystify it. The first thing is, these workspaces are organized in a tree, meaning there is a unique path in KCP that shows where your workspace is. And all we do is in a kubeconfig, we append this path to the URL, and by doing it, KCP knows which workspace you want to talk to. Of course, you still have RBAC in these workspaces and everything, so it doesn't mean you are allowed to, but it's how KCP determines which workspace you want to talk to. Normally, I would show now a little mini demo, but because we have a larger demo planned at the end, you just have to trust me with everything that's on the slide. But what I want to show here, and it's important to me, is, so KCP, it's a binary. You can just start it on your computer. It will start a web server that runs forever and logs out a lot of things. This command also creates a kubeconfig for you called admin kubeconfig and just place it on your local file system. So we can just use that kubeconfig like we would use any other kubeconfig, and we are now talking to KCP in the root workspace, and we can create things like config maps there, and this is the big thing, we can also create other workspaces, other API servers. And this is what we do in the example here. So we create one, then we can get it like we would get any other Kubernetes resources, and we can also switch into it. And this command sounds a bit like magic, but all it does is it edits your kubeconfig and changes the server field to have now the new path. Important part is, in this example here, we created a config map in the root namespace. If we now, in the root workspace, if we now go into the Team A workspace and we try to get that kubeconfig, it doesn't exist. It exists in the root workspace, but it does not exist in the Team A workspace. They are isolated from each other. They have completely different data stores. Does this make sense to everyone? Can we get a quick nod? Okay, sounds good. So we go back to our example. You say, okay, Simon, that's nice. I understand. Everyone gets their workspace. Everyone is happy. But The reality is there's a relationship between these. I have the database team, and they would like to share their APIs with other teams. They don't want it to just exist in their workspace. And this is where KCP is strong. You can think of KCP, it's like the overlord over all of its workspaces because it's just a singular instance. And what it allows it to do is, there's two native objects in KCP called API export and API bindings. And a database team can create an API export, making their APIs available to other workspaces. And then if a consuming team creates a suitable API binding and that matches the API export, then they will sync over the CRDs, or they will sync over the APIs, making them available for the other team. Now, let's look into how we do this a little bit more in practice. So the API export is really as simple as this. It essentially contains a list of resource schemas. Resource schemas are CRDs. It's just a wrapper around CRDs, but it's the exact same structure as a CRD. And it's just a list of them so that we can export multiple APIs at the same time, which can be desirable. And then the counterpart is equally as simple. So we just have a reference in there, and you can see in the reference in the path, this is the path that we saw on this slide with the tree. Like where I had the slide with the tree, this is the exact path, because we need to tell KCP where it can find that API export that it's supposed to match. All right, now you say, Simon, that's all good and nice, but you also said we cannot really schedule things in KCP. So how do we actually fulfill now an order? So we assume we have then somewhere else a database controller running, because we said it cannot run in KCP, so it would run in another cluster. And how would it now know that someone in their isolated Team A workspace has created a database? Because they're separated from each other. And this is where, and this is, I promise, is the last KCP concept you will need to understand for today, the API export virtual workspace comes in. So there is a special feature in KCP called virtual workspaces that allow you to create an abstraction or a computed view of one or multiple workspaces. And there is one for API exports, matching for the database API export. It will get automatically created. It's a little bit black magic, but we'll get into this. And this, again, has a unique URL, which can be used in a kube config that you feed into your database controller. And by having this, if it uses this kube config to watch, it will get notified every time a database is created. And the neat part is, it doesn't only apply to one workspace, but actually if Team B decides, oh, databases are really cool, we want it, it actually also automatically watches them with you without you changing anything in the controller or even restarting your controller. It's just new events get added. All right, sounds a lot like black magic, and unfortunately, partially the reason is because it is. So virtual workspaces are directly built into KCP. They're hard-coded, and it just happens when you create an API export, it just automatically sets up the virtual workspace for you. It's not something that you, per se, control, but it's important for the example, and it's a very powerful feature that exists inside KCP. There are more virtual workspaces for other use cases, but really, I don't want to overflow you with information that's not necessary for the big demo we have planned for the end. With this, Lovro is going to give you an intro to Crossplane.
Okay, hi. So now something a little bit simpler than KCP, hopefully. Okay, do we have people here who never used Crossplane or never touched it? Okay, awesome. So I'll give you a quick intro. Crossplane is big. I just try to compose everything into something smaller, so it won't be a full intro, but we'll touch the most important parts that will be important for this synergy talk that we have now. What is Crossplane? So we like to say that it's like a cloud-native control plane for which you can provision and manage all of your resources. You can compose those resources, and this is one of the strong points of Crossplane, into some higher-level abstractions that later can be used, for example, by your developers to get like a golden path to have self-service provisioning. So we know that Kubernetes is a great control plane, but for containers. And then Crossplane can teach it to manage everything else. And we know that control planes are not a new topic. Cloud providers have been using that for years, but now we can build our own. So how to do it? Let's assemble some granular resources and compose them. But you can think now, like, what granular resources? Like, where do I get them? So Crossplane has a big marketplace with providers, which you can consider like Crossplane tailored operators, which have a set of resources they know how to manage and operate on. And we can use them, install them in our Crossplane cluster to give Kubernetes knowledge how to manage those resources. So let's see if we want to compose like a cluster resource and give our developers just like a cluster interface. In the background, we would have to compose like GKEs, node pool networks, subnetworks. For example, if you're using something like provider GCP that knows how to manage those and manage it from the Kubernetes cluster resource, which is like a network, and do it on the GCP cluster. So in the background, your platform team can compose this into a composition, and you can offer it as a simple, like a cluster interface, an API to your developers. For example, you just give them a limited configuration options, size and region, and this is all they get. Everything else you can do in the background for yourself, and they don't need to know all the complexity around creating and configuring all those resources. So, as I said, it's cloud native, so all the resources are Kube API compatible, so you can use GitOps, kubectl, so on. You don't need no code. You can have code. We'll see about this later, but in general, you don't need to. Okay, how to do it? So I said we want to create some abstractions, and for example, this composite is an abstraction that we can do. We want to declare a composite resource definition, which is basically like a custom resource definition, but Crossplane's custom resource definition. It looks the same as a CRD. You inspect, you define an API group, you define the schema, and that's it. Now you have an abstraction of a NoSQL database. Okay, so what to do with it? How will Crossplane know what to do with that? So we have to define a composition, what I talked about composing, right? And you can say, okay, this composition works on this composite, and then there's a pipeline of functions that work on this composite. Okay, why am I now talking about pipeline of functions? Where are the resources that the compositions should compose? So actually, that is the old way Crossplane used to do it. There was an old composition type patch and transform, where you would have all your resources written down and different patches between them and transformations, which were pretty complicated. And like 1 year ago, we switched to the pipeline mode, where we just have a pipeline of functions that Crossplane runs, and at one end, it gets your input, which is your composite. You can put a lot of stuff there, like other observability resources in the cluster or any other environment configs. And it runs it through a sequence of functions, with each function getting the output of the previous one. And then it gives it back to Crossplane, and Crossplane knows how to generate those resources. So functions are very various. They can be like function Python, function Go templating, function, I don't know, auto-ready. It can do a lot of stuff. You can create your functions, it's not that hard. You have also a marketplace for functions. You can find which ones you need, and you can just put them like Lego blocks and create your own composition for what works for you. Okay, last part, and I'm talking about Crossplane V2 because we were using parts of Crossplane V2 in the demo. Crossplane V2 came out 1 month ago, so the Crossplane team was listening to the feedback from the community and also some of our own frustrations with Crossplane V1, and we made it a bit more useful, intuitive. And some of the major changes there are the composite resources. So those that are your abstractions for developers can now be namespaced. Before there were cluster scopes, which was a problem for a lot of folks. Managed resources are now namespaced. Managed resources are those that providers manage. So now they can be also namespaced and cluster scoped. And the part that will be important for this demo is that compositions now support composing any Kubernetes resource. So before you couldn't compose a config map, you would have to use, for example, Kubernetes operator to compose Kubernetes resources. And now you can use compositions to do it for you. I won't go through the other ones. If you want to, you can check the Crossplane V2 docs. but in general, Crossplane V2 is much better for building applications and not only infrastructure. Okay, and now the demo.
All right, enough theory. You have now learned all the concepts, and we're now trying to put them a little bit together. So what do we want to achieve? So assume you're the member of Team A, and we already said there is supposed to be a database cluster to be used where the actual provider would be hosted. In this case, what we have is basically you order a database, then somehow that request needs to be transferred over to that cluster. The database needs to be provisioned, credentials need to be taken, and then they will be returned. The important part for me here to show is it's a two-way process. You order something, and then you get something back, which is a typical process that's happening in platform engineering. How can we achieve this now with KCP and Crossplane? Now we're putting all the little puzzle pieces together, so it's a good now if you paid attention, because now every single part becomes important. So, first of all, we're using a Crossplane provider for SQL. So this is something that someone else built, the community built, that we can use, and it works on databases and users on the mysql.sql.crossplane.io API. That happens on the provider side. This is plain standard Crossplane. Now the question is, how do we combine these two worlds? Well, the first thing that we learned from the KCP half of this talk is we need to first of all bind the API so that in the consumer workspace that API is available. The eagle-eyed among you have already noticed, wait a minute, Simon, you have here databases.mycorp on the left, and on the right it's sql.crossplane.io. It will make sense in a minute, I promise, but yes, these are two different APIs, and I will explain to you why we are using in our demo two different APIs. But by binding this, we said the virtual workspace gets created or gets configured, so it's also possible to view from the outside, and then this person would start, we would start and create a database. And then, and this is now where a little bit of magic comes in, there's a component called the KCP API Sync Agent, which is something that we've built in KCP to handle situations like this, where the Crossplane provider, it works on a global level. Like all databases are cluster global. And so we cannot just sync over the name, because KCP is truly multi-tenant able, and I showed you that two workspaces, they can create two objects with the same name. If we just use the name, we have a collision. So that's why we have something created called the KCP Sync Agent, and it generates a unique name out of the creation. So it uses, like, we will show it in the demo, but it uses some parts to ensure to template a unique name. And then it creates a database mycorp, and now for Lovro mention comes in, actually the database mycorp is a Crossplane composition, and the reason why we use a composition here is so that we can create a credential secret out of it that is syncable by the API sync agent. So we create a blank secret, it's just a placeholder for a minute. Then the usual Crossplane process starts. So it says, oh, a new MySQL Crossplane.io database has been requested. It creates a database in a user, and it fills the secret with the credentials. And then the KCP sync agent syncs this back into, and this is really important, it syncs it back into the Team A workspace, so that only Team A has access to the secret, which obviously is very, very important. Imagine everyone has everybody's database credentials. That would be kind of bad. And then obviously you can run kubectl get secret on the blue workspace, and then you get it. I know this is a really, really tough chart, but one of the big requests was from last talk was like, show us a practical example how these things can work together. And in reality, we have sometimes limitations where one part is fully multi-tenancy able and one part isn't. And this is what we think a good way to work with this, to make it still feel cloud native. Because after the initial setup, everyone can order as many databases as they want in all their workspaces. Enough slides. Through with the slides, hop into the thing. So, last row, is this big enough for you guys in the last row? Everyone's nodding? Perfect. All right, let's hop into this. So for the demo, we're gonna play now, we do a little bit of role play. So Lovro is the provider, I am the consumer. But in case you ever get lost, you can also see at the bottom, we have prepared the provider and we have prepared the consumer. So if you ever get lost, just look at the bottom where the blue box is where we are at. And then so Lovro is going to start with the provider, and he has a kubeconfig to access the kind cluster where like our database server and so is running.
Okay, so I'll just show you what pods we have running in this cluster. As you can see, we have Crossplane installed, and we have a provider SQL. which is a provider which knows how to manage databases. And we have function Go templating. So this is the function that we'll be using. As it says, it works with Go templates. So it will know how to handle our compositions which use templating. Okay. And now let's see what abstraction we want to show. So let's check the XRDs. Okay, we have a MySQL databases XRD. Oh, German keyboard, yeah. Okay. Oh. Okay, so it's very simple. It specs what you need to know is that the group is database micropio, kind is MySQL database, which today we realized sounds stupid, MySQL database. This is what you get when you tell cloud to build your stuff for you, but okay. And the only thing that is in the spec required is the name. Okay, and I'll leave it at that. So anybody who interacts with this just needs to give us a name and we'll create a MySQL database for them. Okay, let's get a composition. Okay, so this is our composition, not this thing, but okay, and now bear with me. So the pipeline here, or maybe before the pipeline, we see that the composite type ref is MySQL database. So it knows on what objects to work on. And then it takes this when it's created and runs this through the Go templating pipeline. And as input to the pipeline, we give it a template through which it knows what resources to create and how. So I'll just go through the important stuff. Here, the object name is the resource name of the thing that will get synced to us from KCP. And it will be unique, so we will know that it's unique, and everywhere we can use this object name where we need to make sure it's unique. So in the database, we create a database object, which is under the group MySQL SQL Crossplane. So this is not the one that KCP knows about. This is the one that the provider SQL knows about. So that one only knows, okay, I have the name, and okay, I'll create a database with this name. There's no other configuration here. We can create a secret. This is new with Crossplane v2. And in the secret, we can create a password. And this will be the password that the user will use. So we create a user, and the user will use the password secret ref to get this password. And what is important about the user is that the user will have connection secrets. This is a concept in Crossplane as well. When a managed resource has some like credential data or something it wants to pass as a secret, it can write it into a secret if it wants. But also, we can use in Go templating these connection details, and we can create a secret that we want to sync back to the KCP cluster. And as Simon was mentioning, first it's created empty, but then when the user is created, it will fill up this data with the connection details from the user. So like username, password, port, and endpoint. And this part is also important, this label, sync agent, because it will tell the sync agent to which of the consumer workspaces it should sync this secret. So this is using this object name, which should be unique for the database that will get synced. Okay, and now how to tell the world that I'm offering this this service, this abstraction. So we have something called, not this thing, publish resources. And this is already a KCP sync agent concept. This is not connected with Crossplane. And here we can define the resource that we are offering. It's a MySQL database. The naming part is important because now we can template the name that is coming from the KCP workspace into the provider cluster. We prefix it with the cluster name, which is basically the logical cluster name of the KCP workspace. And we just add some suffix to the name. And also, we want the database credentials to be synced back. We can tell in this publish resources that there is a related object or resource that is related to this MySQL database, and we want to sync it back as well. So we say we have a secret that is related called database credentials. And the important part here is this, again, this selector that is doing the match labels. So it will match the labels of the secret that we created in the composition. Please disregard this splitting and so on. It should also be cluster name, but yesterday when we were doing the demo, we noticed that there is a bug there, already filed, maybe already fixed.
Well, potentially already fixed.
Yeah, if Christoph is on it. And yeah, so basically it should be like also a cluster name and object metadata, blah, blah, blah. But yeah, it's a bit confusing here. Okay, let us, German keywords. Okay, let us apply this. Okay, I published. We are now serving databases.
So I take over now as a consumer. So really important. If we look at my kubeconfig, I have a kubeconfig space to KCP, and you see I'm in the root consumer workspace. So the first thing I need to do is obviously create our API binding. I will not show it again. I think this was clear. It's 5 lines of YAML, and we're running short on time, but like we can have a little bit more in discussion. So I create the API binding, and this makes the database's API now available in my workspace. And now what I can just do is I can create a database, and just to show you what it looks like. So it looks like this is really short. It just has a name. As Lovro mentioned, there's only one spec field. So yeah, let's apply it. And then, prayer to demo gods.
No.
Yeah, it happens. So there should be the secret now here. Sorry about that. I guess it happens.
It's here.
We just had to wait. We're too impatient. So here it is. And these are the credentials coming back from the provider cluster that now are available to the consumer. All of this has left you probably with the question why it's so complicated. And this is a question that comes up. And we just need to talk about multi-tenancy degrees of freedom. Because what this system allows us is a lot of freedom. First freedom is, okay, this is done directly in KCP. We can just have multiple consumers. Other thing is we can have multiple providers, and each provider can have their own cluster, and they can have their own API exports. And then, and this is the last part that's important, we have also a degree of freedom how many instances of a crossplane provider we need. So it wasn't shown in the demo, but with this architecture, we can use one provider instance to serve all workspaces, and we do not need to scale up the amount of crossplane providers with the amount of workspaces that exist. We can if we want to, it's a degree of freedom, but we don't have to. And I hope this made sense. We know it's a bit complicated, but we really wanted to show this off how this looks in practice. There is a GitHub repo I will show you in the end where all the steps are, so you can try it on your laptop. It works completely locally. And yeah, have fun out there. Try KCP, try Crossplane. Was a pleasure for us to host. We have some time for questions, but we'll also be afterwards here available, or I'll also be at the Kubernetes booth. Yeah, sure. So backstage KCP integration, there's currently no integration. I'm happy to talk with the person who wrote this that could give me a bit more insight also into backstage, what we could sync there. So backstage, I think, is interesting, like especially backstage KCP integration. I have to say we're not there yet, but if the person, I would love to talk to you. Please come up afterwards. Can I exchange the data store of KCP? Theoretically, yes. Everything that works with Kubernetes API server would work with KCP as well. So if you're using this new Foundation DB etcd shim, that would work theoretically. We have not tested it, but it would work. Can I use KCP for other use cases than platform engineering? Yes, I would say yes. Whenever you need a couple of API stores, you can use it, especially also for local testing, if you just quickly need your own API server to run a controller against. Important part is you don't get scheduling. You don't get any of these container features, but if you don't need them, yes, you can use them as well. Maybe quite low level, what's the difference between a namespace and a workspace? So a workspace is like an API server, meaning a workspace like a Kubernetes API server can have an unlimited amount of namespaces. and you can create them. So it's another layer of organization that you have. Important part is, of course, workspaces are completely separated from each other. Namespaces inside a workspace are like in a Kubernetes cluster, they are in the same general sphere. Do we have, can you scale KCP horizontally? Yes, you can. There is a sharding concept where you can control which workspace gets stored onto which shard, which then means which gets replicated into what etcd. So yes, you can run it with multi-etcd and store workspaces on different shards. Then there's a crossplane question. Lovro, all crossplane questions to Lovro.
Okay. How do day 2 ops fit in crossplane XRDs? Actually, for day 2 ops, there's a new thing called operations, which is like one-off running of your function, and you can do stuff there like backups and so on. So check that out in the docs. I think there was also one more question about Crossplane v2 supporting Proto v6 and Terraform plugin framework. So this one is more connected to the object-based providers, I would guess. I'm not sure. I think not. I know that there is a topic around this. I saw it here and there, but I'm not involved with that part of Crossplane. Please ask in the Crossplane Slack repo. Slack.
I think all questions have been answered.
No.
Why can we see the pods in the provider workspace? I thought we only sync the DB resource. Okay, so the provider workspace is a regular Kubernetes cluster with pods and everything, which we need to run Crossplane and the providers. So this is why you can see pods there. All the KCP stuff is containerless, let's say.
Okay, the other
How to handle breaking API changes when one team is very slow in adoption. Hurry them up. I don't know. That was a complex question. Maybe later come forward and we can try to discuss that.
Yeah, so one thing just in general on this topic is definitely with API exports, you can export different versions of your API in different exports. So you can have a separation on that level.
Okay.
But how to hurry up slow adopters is, I think, beyond this talk. I think there's no technical solution we can offer for this.
How can the database team access the database from team A? Is the secret also syncs to the database team workspace? The database, the provider workspace also has that secret.
Not the workspace, but the cluster, the provider cluster.
The provider cluster, sorry. The provider cluster also has the secret. So the database team can access it.
Can I do all of this without the sync agent? At the moment, no. The sync agent is required because multi-tenancy is tough to do in Crossplane. If we were to write a provider that's using multi-cluster runtime instead of controller runtime, then this would be possible. But this is something we could not fit into this talk. This will be in the next evolution of this talk. Because here we really wanted to give you an example of what's possible today. No.
Will Upbound replace its vCluster-based tenant installation with KCP? That's a complicated question. Let's say that there are talks about it. I'm not sure how much I can, reveal. Have you tried to run KCP with another Kubernetes cluster as a workload?
Yes. Yeah, you can run KCP in Kubernetes without issues. We also have a Helm chart, and we also have a Kubernetes operator for this as well.
Is it secure for consumers to be able to create API bindings on their own? Can these objects enable exposure of data? So, go ahead.
I mean, so first of all, you need to have a matching API export, and then they are your objects. Like no other objects get exposed to you. The only thing I could imagine is if you accidentally create an API binding and then create objects of that type, but that type is only available once you have created the API binding. Why can we see pods in the provider workspace? I thought
this one we did.
Okay. Then?
I think we're done. We will be back. A round of applause for our speakers.
Hey, thank you guys for staying till the end. Thank you for all the questions. And yeah, we're ready to take on more questions and more detailed questions as well.
We will be back in 5 to 7 minutes with our next talk.
From ContainerDays Hamburg, This video is proudly presented by Dux IT.